Welcome back to our channel. Today we're diving into the fascinating world of electric circuits. Whether you're a beginner or just need a refresher, we'll cover the fundamental concepts that form the backbone of electrical engineering. So let's get started. First things first, what is an electric circuit? Simply put, an electric circuit is a closed loop that allows electric current to flow. It consists of components like resistors, capacitors, inductors, and power sources, all working together to perform a specific function. At the heart of every circuit is the power source. This could be a battery, a generator, or any device that provides electrical energy. Next, let's talk about current. Electric current is the flow of electric charge typically measured in amperes. The flow of current in a circuit is considered from the positive terminal to the negative terminal of the power source. This is called conventional current. It's worth noting that the charges that are moving in a circuit are negatively charged and are called electrons. They move from the negative terminal of the source to the positive terminal. This is called electron flow. It's important to understand, though, that in circuit analysis, it is the conventional current that is used. There are two types of current, direct current or DC, where the flow of charge is in one direction, and alternating current or AC, where the flow changes direction periodically. Now let's discuss voltage. Voltage is the electric potential difference between 2 points in a circuit and is measured in volts. It's what pushes the current through the circuit. Think of it like the pressure in a water system. The higher the pressure, the more water can flow. Another key concept is resistance. Resistance is the opposition to the flow of current measured in ohms. Every material has a different level of resistance. For instance, copper has low resistance, making it a great conductor, while rubber has high resistance, making it an excellent insulator. To understand how these elements work together, we use Ohm's law. Okay, Ohm's law states that voltage equals current times resistance, or V equals I times R. This relationship helps us predict how the circuit will behave under different conditions. Now, let's take a closer look at circuit configurations. The two most common types are series and parallel circuits. In a series circuit, components are connected end to end, meaning the same current flows through each component. If one component fails, the entire circuit stops working. On the other hand, in a parallel circuit, components are connected across the same voltage source. This allows multiple paths for the current to flow. If one component fails, the others can still function. Lastly, we need to consider power in circuits. Power measured in watts is the rate at which electrical energy is converted to another form, like heat or light. Power can be calculated using the formula P equals V times I, where P is power, V is voltage, and I is current. To sum it all up, electric circuits are built on the principles of voltage, current, resistance, and power. Understanding these fundamentals is essential for anyone interested in electronics or electrical engineering. Before we wrap up, let's take a moment to explore some practical applications of these concepts in real-world scenarios. Understanding how voltage, current, resistance, and power interact can help you troubleshoot common electrical problems and design your own circuits. For example, think about your home appliances. Each device has a specific voltage requirement and current draw. When you plug in a toaster, it uses a certain amount of power, which is calculated using our formula, P equals V times I. If the toaster draws too much current, it can trip a circuit breaker, protecting your home from potential hazards. Now let's consider a simple circuit project you can try at home. You can create a basic LED circuit using a battery, a resistor, and an LED. By varying the resistance, you can see how it affects the current and brightness of the LED. This hands-on experience will help reinforce what we've learned today. Remember to always use the correct resistor value to prevent the LED from burning out. This is a great way to apply the concepts of voltage, current, and resistance in a fun and engaging way. Leave in the comments if you need me to make a video on how to determine the correct resistor value. As you continue your journey into the world of electronics, don't forget to explore more complex circuits like series and parallel configurations. Each configuration has its own unique characteristics and behaviors that are fascinating to study. A concept for another video. Understanding these configurations will not only deepen your knowledge but also enhance your skills in designing more advanced projects. And remember, every great inventor started with just a spark of curiosity. So take what you've learned today and apply it to your own projects. Maybe you want to build a simple flashlight circuit, or perhaps you're interested in creating a more complex project like a home automation system. Don't be afraid to experiment. Use a breadboard to prototype your designs. It's a fantastic way to visualize how voltage, current, and resistance interact in real time. You can see how changing a resistor affects the current flowing through your circuit, or how adding components in series or parallel alters the overall resistance. And speaking of experimentation, consider diving into some online simulators like Tinkercad. I will leave the link in the description below. They allow you to build and test circuits virtually, giving you a risk-free environment to explore different configurations and troubleshoot issues without the need for physical components. As you gain confidence, challenge yourself with more intricate projects. How about creating a simple robot or a sound-activated LED display? The possibilities are endless, and each project will teach you something new. Now, let's wrap up by taking a quick moment to recap the key takeaways from today's session. Understanding voltage, current, and resistance is foundational to all electronics. Remember, voltage is the push that moves current through a circuit, while resistance is what opposes that flow. Whether you're working with series circuits where the same current flows through all components, or parallel circuits where the voltage remains the same across all branches, grasping these concepts will empower you to tackle more complex designs. Thank you for joining us today. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell for more content on electrical concepts. If you have questions or topics you'd like us to cover next, leave a comment below. Until next time, keep experimenting and stay curious. Bye-bye.